Hello, hi everyone. Welcome to the Studio in the Brand. This is our Shiva sir. Today we are going to discuss about electric current. Electric current. Electric current. CBSE Grade-10 Physics. So this chapter is very important. CBSE CBSE Grade-10 CBSE Grade-10 Physics. So this chapter is very important. That's why we are discussing. Okay, again and again. And actually we need to do problems also on this. So I'm not getting time to do problems. Only the complete time is going for explanation. So I'll try my level best to discuss problems also. Okay, so today we will discuss problems also, topic wise. And on particular topic, what type of questions they will ask, how to answer it, and where we need to concentrate the most. So that and all everything we will discuss. So those are, so I hope you already know that the chapter. So the topics, what are the contents are there. Those who are watching new, those who are new to the channel, so please do like and share and subscribe to Study in the Brand. You'll get more updates, more live classes, whenever it is coming, you'll get to know. Okay. So whenever I'm taking live class, you'll get an update. So try to subscribe my channel. So do like, share and subscribe my channel for more updates. Okay. We will discuss now. So complete electric current. Electric current will discuss. Electric current is nothing but I equal to Q by T. I equal to Q by T. So SI unit of current is ampere. SI unit of current is ampere. SI unit of current is ampere. So you have to write the small letters. You have to write the small letter. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. Once again, I hope you can observe here. Electric current, the rate of flow of charge. Actually, the net charge is flowing through unit cross section area per second. If you go in depth of the explanation. Okay, so you know electric charges and fields in +2. So in the topic, we'll discuss more points. Those are there in grade 12. Now, so this is for CBSE grade 10 physics. So that's why related to that topics we are discussing related to CBSE grade 10. Okay. Now, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is 1 ampere equal to 1 coulomb per 1 second. Okay. Now, so inside of the conductor, if you are taking here, there are many charges will go. So only one charge it will move. Only two charges if it is force. We can't say current is flowing. Only one electron, two electron, or if it is goes inside of the wire, we can't say current is flowing. So there are many charges are flowing inside of the conductor. Many charges. So that is nothing but quantization of charge. Q equal to plus or minus Ne. Sir, you are taking plus or minus Ne. So what is the reason? The reason behind of this one is plus or minus. The reason behind of this one is, so positive charges are there, at the same time negative charges are there. Positive charges are there, negative charges are there. Okay, positive charges and negative charges. So both are moving inside of the conductor, right? Okay, so inside of the conductor, positive charges will be there, negative charges will be there. Then only we can able to say current is flowing inside of the conductor, right? That is Q equal to plus or minus Ne. Q equal to plus or minus Ne. Now, N is the number of electrons. Okay, number of electrons moving inside of the conductor. On one electron, this point is very, very important. So I am saying once again, on one electron, 1.6 into 10 power minus 19 coulomb on one electron. 1.6 into 10 power minus 19 coulomb is present. So we have to remember this value. There is no other option. So sometimes they won't give an exam. This value they will not give an exam. In the question they won't give. So you have to remember that. Okay. Without remembering this value, if you go to exam directly and if you substitute wrong answer, again is a problem. So try to remember this value, 1.6 into 10 power minus 19 coulomb. On this one, two more questions they will ask. Charge of an electron. How much is the charge of an electron? So on one electron, how much charge is present? On one electron, how much charge is present? Is the less than this value will exist? So charge of an electron, first point is how much? How much, first question? 1.6 into 10 power minus 19 coulomb. That is the first point. Second point is the less than this value exist? Means less than this value will exist? No, because on one electron, 1.6 into 10 power minus 19 coulomb. That is fixed. So, okay, sir, you said on one electron this much coulomb is present. In 1 coulomb, how many electrons are present? So, I want to know that value. Can you explain that? Yeah, definitely I will explain. So, that is on one. So, in 1 coulomb, so okay, in 1 coulomb, simply you can take this value down 1 by 1.6 into 10 power minus 19. We know that 1 by x power minus 2 you can take x power 2. 1 by x power minus 3 we can write x power plus 3. 1 by x power minus 4 we can write x power plus 4. Okay, so if it is denominator, numerator, denominator. In the denominator, so it is minus. If it comes in the numerator, it will become plus. So same like this here also. In the denominator, okay, so 10 power minus 19 is there. If it is comes in the numerator, it becomes plus, right? Yes. So I am writing now. That is, we can also write like this. 1 by 1.6 into 10 power 19. So you have to solve this value. 1 by 1.6, you have to solve this one. If you solve, how much you will get it? If you solve, how much you will get, we will see. Now, 1 by 1.6 into 10 by 10 into 10 power 19. If you solve this one, that is 10 by 16 into 10 power 19. If you solve it, get 0.625 into 10 power 19. That is in 1 coulomb. Okay. So in 1 coulomb, if you are taking 6.25 into 10 power 18. Very, very important. So make sure that you are remembering this value. This value is very, very important. Okay. So remember this value. This value on 1 electron, how much charge is present? In 1 coulomb, how many electrons are present? These 2 points are very, very important. These 2 points are very, very important. So make sure that you are practicing these 2 values. Okay, remember these 2 values. So So in MCQ's point of view, these 2 points are very important. MCQ's point of view. And this question also they will give, and sometimes related to, so total I equal to Q by T, right? I equal to Q by T, that is I equal to NE by T, NE by T. So related to this also, related to this formula also, they will ask one question. That is, so in 1 ampere of current, how many electrons are flowing? That is a question. In 1 ampere of current, how many electrons are flowing? So time in 1 second. Time is 1 second they will give 1 ampere. So here on 1 electron how much charge is present, that we have to remember. This value you have to remember. Then by that 1, so n equal to 1 by 1.6 into 10 power minus 19. However you are solving this one, same thing you have to solve. You will get the answer. Right? So this is about electric current. So definitely related SI units are very, very important. I am saying to you, SI units are very, very important. So remember the SI units of electric current, charge and time. So one more question. This value, these 2 values are very important. You have to remember. And the process and this final formula. Okay. Related to this one, so they'll ask questions. And one more point, electrical appliances. Related to electrical appliances also, they will ask questions. We'll see. Now, so we'll discuss electrical appliances. Electrical appliances. So anyway, directly I will go with that. Electrical appliances. First one is cell. Positive terminal, negative terminal cell. Second one is battery. Positive terminal, negative terminal battery. And the third one is cell, battery. Next one, open switch. Open switch. Fourth one is closed switch. Closed switch. And fifth one, open switch and closed switch. Open switch and closed switch. Next one, resistor. Resistor. So about resistor, I will discuss few points. Point number 1. So resistor. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. It is a device. Resistance. Resistance is the phenomena of opposing the electric current. Once again, resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Phenomena of opposing the electric current. Next one, ohm. SI unit of resistance is ohm. And fourth one, so symbol I am taking like this. Okay. So these 4 points are very important related to resistor. Related to resistor, these 4 points are very important. So make sure that you are learning. Resistor, resistance, ohm and symbol. This is the symbol. Okay. Coming to the rheostat, 6th one. Rheostat we are discussing now. Rheostat is a device. Rheostat. Rheostat is a device which is used to regulate the current without changing the voltage source. Rheostat is used to regulate the current without changing the voltage source. Okay, so this is the rheostat is a device which is used to regulate the current without changing the voltage source. Without changing the voltage source. I hope it is very clear to you all. Next one, ammeter. Ammeter. Seventh one, ammeter. Positive terminal, negative terminal. Eighth one, voltmeter. Voltmeter. Ninth one, wire joining. 10th one, wire crossing. And 11th one, bulb. Bulb. Okay. So I hope it is very clear to all. Check once. So cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, bulb. Okay. Ammeter is a device. Ammeter is a device which is used to measure the current. Ammeter is a device which is used to measure the current. Ammeter will be connected in series combination in the circuit. Coming to the voltmeter, voltmeter is a device which is used to measure the potential difference, which is used to measure the potential difference. So voltmeter is connected in parallel combination in the circuit. Coming to wire joining, wire crossing, bulb. Okay, so these are the electrical appliances. Electrical appliances. And coming to the one more, so related to this concept, related to the electrical appliances, about resistor is very important, rheostat definition is very important. Okay, resistor, rheostat, anyway, ammeter, voltmeter. So what is the purpose of ammeter, what is the purpose of voltmeter, how you are connecting, related to that questions they will ask. So that's enough. And they will give the electrical appliances, we have to write, we have to draw the diagram. So mainly 3 marks question they may ask, 3 marks question, that is they will give the electrical appliances. So like 6 volts battery is connected, and resistor, rheostat, ammeter, voltmeter, bulb. So they will give the devices, we have to draw the schematic diagram. Schematic diagram is nothing but circuit diagram itself. Okay, schematic diagram means so a diagrammatic representation and logical connection of electrical appliances. Diagrammatic representation and logical connection. Must we have to connect. However, so voltmeter cannot be connected in series, ammeter cannot be connected in parallel. So there must be a logic while connecting the electrical appliances in circuit. So that's why, okay, diagrammatic representation of electrical appliances and logical connection. So diagrammatic representation and logical connection of electrical appliances is called electrical circuit or schematic diagram. Schematic diagram, actually schematic diagram or circuit diagram, not electrical circuit, circuit diagram. Okay, now electrical circuit will discuss. Electric circuit. Electric circuit. Okay, Here, this is I am taking the battery. So here I am considering the switch. 1 minute. Okay, so electric circuit, electric circuit, ammeter, bulb, so here you can take current is passing positive terminal, negative terminal, positive terminal, negative terminal, current is passing. Okay. Electric circuit is nothing but a continuous and closed path of an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay, so check once here. A continuous and closed path of a continuous and closed path of an electric current is known as an electric circuit. Here, point number 1, conventional current. Conventional current, and second one is electric current. Electric current. Sir, what is the difference between conventional current and electric current? The flow of positive charges is known as conventional current. The flow of positive charges is known as conventional current. The flow of electrons is known as electric current. The flow of positive charges is known as conventional current. The flow of electrons, the flow of positive charges is known as conventional current. The flow of electrons is known as electric current. So conventional current means, so flow of positive charges. Electric current is nothing but flow of electrons. So conventional current, so positive charges will move from positive terminal to negative terminal. Electric current, so electrons will move from negative terminal to positive terminal. And one more point here, that is conventional current, that is the positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential. Very, very important. So there is one question on this. Will electrons flow positive terminal to negative terminal or negative terminal to positive terminal? So electrons will always move from negative terminal to positive terminal. Electrons will always move from negative terminal to positive terminal. Negative terminal to positive terminal, that is low potential to high potential. Low potential to high potential. Very, very important. Electric current. Electric current. I hope it is very clear to you all. Next one. Next we'll discuss about potential difference. Actually related to this one, they will ask about questions, conventional current and electric current definitions they will ask. And yeah, just now I explained, no? will electrons flow from positive terminal to negative terminal or negative terminal to positive terminal? So that question. And the electric circuit definition they will ask. Electric circuit definition they will ask. They will ask about electric circuit definition, and they will ask to draw the diagram. They will give the electrical appliances like a cell, battery, bulb, and ammeter, voltmeter, switch. So these points they will give. They will ask to draw the diagram. You have to draw the diagram. So like a schematic diagram, like that they will ask. Coming to the electrical potential and potential difference. Now we'll discuss about potential difference and electrical potential. Potential difference. Potential difference. Potential difference is nothing but, so I'm taking here. So this the, okay, so this is one point, this is one point. We are doing some work. To bring unit positive charge. We are doing some work. So W is a work, positive charge. We are doing some work to bring unit positive charge from one point to another point. Within the conductor. Very, very important. Within the conductor, if you are doing, that is a potential difference. Work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. So that is V equal to W by Q. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. So related to this one, potential difference they will give and charge they will give. They will ask to find out work or sometimes volt. Yes, and yeah, like any two quantities they will give. One quantity we have to find out related to this formula, and sometimes energy also they will ask. That is nothing but work only. So V equal to W by Q. W they will ask to find out. So we have to find out. And coming to the definition, 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 volt is defined as 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. That is called 1 volt. Clear? So once again, 1 volt is defined as 1 joule of work is done to bring from one point to another point. Okay, 1 coulomb of charge. 1 volt is defined, 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay, done. Finally, coming to the electrical potential. Electrical potential. So what is electrical potential? Electrical potential is nothing but, so this is the infinity. So I am taking this is a positive charge. Infinity I am taking positive charge. So we are doing some work to bring that positive charge from infinity to the required field. Sir, only this point. No. Suppose I am considering the required field. Okay. So this is infinity point. We are doing some work. So some work we are doing to bring unit positive charge from infinity to the required field is called electrical potential. I hope it is very clear to you all. Right? Yes. So potential difference and electrical potential. So these 2 points are very, very important. So expected problems on these 2 concepts. Problems they will ask. Okay. So like not only this concept, like from entire the chapter, so each and every concept they will ask problems, like right from quantization of charge, electric current, and coming to the uh, potential difference and electrical potential and electrical circuit, related to electric circuit they will ask questions, and conventional current, electric current. Okay, so related to this one, surely one question will be expected, because that much important it is. Next one, now we are discussing Ohm's law. So we'll discuss Ohm's law. Ohm's law is nothing but, we'll discuss about Ohm's law. So Ohm's law we need to discuss. We'll discuss Ohm's law, and electrical resistors are connected in series. Resistors are connected in parallel, and difference between resistance and resistivity, electrical power, heating effect of electric current. So we will discuss all those points. Okay, so we'll take a short break. Not short break, little break. Okay, so around until 11. Until 11, we'll take break. After that, we will discuss. Once again, we'll join at 11 p.m. Okay, so join at 11 p.m. We'll discuss more points related to electric current. So thank you so much for joining and attending and listening the class. So if you like the content, if you're new to the channel, so please do like, share, and subscribe to Student the Brand. Okay, so this is Eva Seva sir from Student the Brand. Thank you so much. We'll see you in the next class.